Welcome.
You're well within your right to do that.
All right, well, welcome everyone. My name is Fernando. We're going to be walking through the new contributors workshop for Spinnaker. So basically the goal of today's workshop is to make sure that you have the tools that you need to start working on Spinnaker, especially as you go through the rest of the hackathon, but beyond as well. So let's go ahead and get started. I'll give you a quick run of show on like what we're planning on doing today. So before we get started with any me talking to you for a little bit about Spinnaker and Kubernetes, we're actually going to clone a few repositories and we're going to start some builds in the background so that you are ready to go once we're ready to start writing some code. So some of these services, they take a while to build locally. So we just want to make sure we get that started beforehand. So I'm going to go ahead and kick us off. And let's go ahead to this Spinnaker Hackathon new contrib manifest. Actually, you know what? Before we get started, I'm going to put a few links throughout the workshop in the Zoom chat. So the first one that I'm going to put in there is the Spin Contrib worksheet. So this is what we're going to be working off of today. So if you go ahead and click that link, you'll go ahead and get access to all of the commands that we're going to be running today. So the first one is going to be this Spinnaker Hackathon new contrib manifest repo. So what we're going to do is we're going to navigate to this in Chrome, and then there's this little green button here that's going to say use this template, and we're going to go ahead and create our own repository. And the reason we want to do this is because we want to have a Kubernetes manifest that we can apply within our own cluster. And I'll explain what this manifest is doing once we get to that point in the workshop. But again, let's just make sure that we have this in our own space. So you can go ahead and just give this a repository name, give it whatever description you want. You can choose to make it public or private. There's no credentials in this repository, so there's no need to worry about that. You can go ahead and click create repository from template. It's going to go ahead and generate your repo. And then go ahead and clone it to your local machine. So I will go ahead and create a new terminal here, and then I'll go to where I store all of my Git things, and I will go ahead and git clone my manifest for workshop. And we'll go ahead and work from this manifest, apply it to the cluster once we get to that point. So we'll give you a minute there to catch up, and then we'll go on to the next two repositories that we're going to clone to our local machine. So let's go ahead and move on to the next repository. So we've got two projects that we're going to be working with today, and we'll explain the goal that we're going to go through in a moment here. So for now, let's just make sure we navigate to GitHub /Spinnaker/Orca. Let's go ahead and clone that to our local machine. And why don't I just reorder these for now? There we go. Okay. And while you're waiting for that to clone, it might take a little bit. Make sure you go to Spinnaker deck. I'll paste that in chat as well. You can go ahead and clone that repository for your local machine as well. All right, so we'll give that a moment to clone. And in the meantime, let's see, I want to go over here. Let's go ahead and introduce ourselves a little bit. So I'm going to paste a link in here, and if you could navigate to that link and answer a few questions, that'd be great. The purpose of these questions is one, just to get a sense for where everybody is joining us today. So that's our first question here. And then the next two questions are going to ask you about your Kubernetes knowledge and your Spinnaker knowledge. So I want to make sure that the content for the workshop today is tailored to only what you need, and we're not covering any material that you're not already familiar with. So I myself, I'm based in Portland, Oregon, up here in the upper left northwest of the United States. It's a little bit cloudy today, but that's not bad. So it looks like we have some folks joining us from Florida. That's great. I hope you're staying safe indoors. And looks like we have a few folks joining us from India, so that's exciting. And Palo Alto, so that's great. All right, so I'm going to open up the next question here. So I'm curious to know what your level of expertise is with Kubernetes. So not at all. I've never heard of Kubernetes before. Somewhat, like I've messed around. I've used kubectl for a little bit. Very familiar. I've written my own operators. I've worked quite a bit with administrating Kubernetes clusters. And then if you just want to mess with me, you can tell me that you have 10 years of Kubernetes experience, but I'll know that's not true. Okay, looks like we have a pretty good spread. So many of you are somewhat familiar and some of you are very familiar. So that's great to hear. So we won't spend a lot of time talking about Kubernetes concepts today. And the next question is, how familiar are you with Spinnaker? So not at all. This is your first experience with Spinnaker. You've never done anything with it before. Somewhat familiar. Maybe you've used it as a user. Very familiar. You are writing plugins. You're operating your own Spinnaker cluster. You're very familiar with how all the code is laid out. And then finally, if you like sailing, just let me know. All right. So it looks like the spread is quite a bit larger today. Looks like some of a few of you are very familiar. Some of you are not familiar at all, and many of you are somewhat familiar. So that's great. So I think we're going to focus a little bit more on Spinnaker today than on some of the other things that are helping us operate Spinnaker here. So let's see. Let's continue on. Okay, so hopefully by now you've managed to clone these 3 repositories. So what I want to get started before we go into more of this conversation is to just go into each of these projects and start a build. So just so that we have it both on the same screen and I don't have to keep switching back and forth, I'm going to create 2 splits here. And I'm going to go into the Orca project. And so let me just make sure that I am on the right branch. Perfect. So I'm going to be on the master branch. And then just to get started, I'm going to type in this Gradle W build command. And so for those of you that are not familiar with Java or the Java ecosystem, Gradle is a build tool that helps you manage dependencies, build projects, run the code. So we're just going to run build here. And what that's going to do is that's going to start downloading dependencies and building the project for you in the background. So this is going to make sure that it goes a little bit quicker once we get to the rest of the project. Okay. So the next thing we want to do is we want to go to git deck. And we're going to want to run the yarn command. And so deck is the front-end UI for Spinnaker. It uses a bit of a different tool chain. Yarn is similar to Gradle in a sense that it helps manage dependencies and build your project for you. So just go ahead and run the yarn command, and that's going to go and start the build process. So we're just going to let this sit in the background, and we're going to go back to our workshop overview here. So before we go any further, I just want to make sure I open up the opportunity for folks that are having issues so far. Like, are you able to clone everything? Are you able to start the build process? Okay, let's go ahead and move on. All right, so the next thing that we're going to talk about is understanding Spinnaker architecture. Ashish is asking, do we have instructions somewhere? Yes. So if you, I don't believe you can see the full chat history if you join after we start. So I'm just going to go ahead and repaste that link. You can go ahead and follow the instructions there. Even if you fall a little bit behind, you can come catch up and yeah. Okay. So we'll talk about understanding Spinnaker architecture. Then we'll talk about the goal that we're going to accomplish today. We'll go through how to install Spinnaker and then work with Orca and Deck to accomplish our goal. And then we'll kind of put it all together at the end. And we'll talk about where you can go from here. So before we go any further, I want to make sure that we just lay it out here. We're going to cover a lot of content today. So if at any point you feel like you don't understand something completely, or maybe you feel like you're falling behind and you should be with the group, don't worry. 100% fine. It just means you're human. So that's why we're posting the link here so that you can follow along afterwards. And we're also going to post this recording after the session. One thing we're also going to do is we're going to send a follow-up email at the end of the day today for folks that attended yesterday and this morning. And we'll kind of walk through a summary of what we did and where you can go from here. This isn't the only way to install and develop Spinnaker. If you've been to the Spinnaker IO website, you'll see there's a couple other approaches. The reason we're choosing this approach today is that because it minimizes the complexity of standing up Spinnaker. So we're basically doing a bunch of steps before you up front to make sure that we can focus more on the development side of things. So if there's a workflow that works better for you or makes more sense for you, then I totally encourage you to explore that and see what works best for you. All right, so let's talk a little bit about Spinnaker architecture. So many of you are familiar, somewhat familiar, and a small amount of you are very familiar with Spinnaker. So we're going to talk a little bit about all of the services that are involved in Spinnaker for those of you that are somewhat or like more users of Spinnaker. So is there anyone on the call that knows what any of these services do? Any one of them?
I know what CloudDriver does.
You know what CloudDriver does? Chris, tell us what CloudDriver does.
It is responsible for interacting with cloud providers to make changes to infrastructure and to pull information about the current status of infrastructure.
That's exactly right. Yeah, so CloudDriver is a really nice abstraction that all of the services in Spinnaker can use so that they don't have to worry about the minutia of like what AWS calls their virtual machine versus what Google Cloud calls it and all the API calls related there. Is there anyone else that can speak to a service on this diagram?
You speak about Orca. It's the orchestration engine, so it manages all the pipelines and stuff.
That's very good. Yes. So Orca, as we just mentioned, is our kind of our orchestration layer, and it makes sure that all of the services that talk to it can perform some action within the cluster. Anybody else? Okay, that's okay. We can go ahead and talk about each of these services in turn. We're going to keep this really brief. The purpose of talking about all of these services now is as you go through the rest of the hackathon, think about what you want to accomplish in the hackathon, and then maybe this helps you choose a particular service to work on rather than trying to like figure it all out for yourself. So I'm just going to go from top to bottom, starting in the upper left. So I'm going to talk about Deck first. So Deck is one of the services that we're going to be working with today. It's the user interface for Spinnaker. It's kind of the front door for everything that a typical user will see. It allows you to perform a number of actions, including the most important, which is starting deployments. The way that Deck interacts with Spinnaker is through a service called Gate. Gate is kind of the front end for the API of Spinnaker. So Deck exclusively calls to Gate, but Gate essentially calls every single service inside of a Spinnaker cluster and makes sure that requests are routed accordingly. The next service is Igor. So if you are using an existing CI system like Jenkins, or if you're storing your containers in a service like Docker Hub, then Igor is responsible for interfacing with those services and providing an abstraction for all the other services in Spinnaker that require access to those CI systems. So moving right along. So now on the second row, far left, we have Kayenta. So if you're more mature or you're further along in your continuous delivery journey, Kayenta is an automated canary analysis service. So the way that you would use Kayenta is you've got a pipeline, you've got one version of a service and you've got another version of the service, and you want to see if that newer version is not actively breaking your user's experience. So you would use Kayenta to automatically gauge metrics between the two services and then determine whether your new version is healthy or not. The next service, Orca, we've already touched on, so I'm going to bump over to Echo. So Echo is essentially the event bus for Spinnaker. So any trigger or any webhook item or any other sort of event that happens in the system flows through Echo, and we'll distribute those events to anybody who's interested in listening. So a good example of that is Igor. Whenever a Jenkins job is finished, Igor will understand that that job is finished. It will send a notification to Echo, and that will distribute the trigger everywhere else in the system. The next service we have is Fiat. Fiat is the authentication layer for Spinnaker. It provides both auth-N and auth-Z. So authentication, whenever a user wants to log into the Spinnaker UI, for example, Fiat has the ability to integrate with SAML providers and a few other authentication protocols so that you can gate access to Deck, no pun intended. And then it also provides authorization. which is kind of authorizing API calls between services. And then finally, on the bottom row, we have Roscoe. So if you're in the EC2 world and you're baking AMIs in Amazon, or you're building some other image for GCP, or even if you're baking a Helm chart or a customized repository, Roscoe is the service that is going to handle that and provide that abstraction for the rest of Spinnaker services. We already mentioned Cloud Driver, our cloud abstraction service. And then the last one is Front 50, which provides an abstraction layer over backend storage. So anytime you need to save an application or a pipeline, then that's what that service is for. So we have a question here from Chris. So the question is there support for SSL auth between these microservices? There is. There is support for MTLS in Spinnaker. It's a little bit manual, so there isn't a lot of automation to help you out there, but it is possible. Otherwise, these services are usually not exposed to the public internet, so they're just kind of talking to each other. And Gate is usually the one that's making sure that somebody is authenticated before they talk to the cluster. Okay, so are there any other questions before we move on from our mini architecture overview? Okay, so let's go ahead and look at kind of the finished product for what we're going to be doing today. So I'm going to make sure that my Spinnaker is running here. Okay, so what I have currently is a local version of Deck. So I have modified this. This is kind of the end of the demo. If we've done everything correctly, this is what you should see in Deck. So what we're going to do today is we're going to add a new stage to Spinnaker. So if you're familiar with Spinnaker, we have the ability to create pipelines for our applications. And so we're going to just have a pipeline with a single stage called MyStage, which is of stage type MyStage. So this is something that doesn't exist in the current Spinnaker installation. So we're just going to show you what it takes both to add a stage in Orca and to add a stage in Deck. So it kind of gives you a flavor for how you would modify Spinnaker and see those changes end to end. So if we've done everything correctly, what we're going to see is we're going to see our pipeline can successfully execute. We're going to populate some information. We're essentially going to have Orca send some information back to Deck for it to render. And then we should be able to see the duration that we spend in each task status. Now, before we go further here, I want to outline, or I want to call out, this isn't the only way to create a stage in Spinnaker. So creating new stages is one of those really excellent ways to extend the usability of Spinnaker for your organization, but it's not the only way to do so. This is perhaps one of the more mature ways to do so. You're actually extending Spinnaker itself to support the stage, but there are two other approaches that you can use to extend Spinnaker. Another one is called a pre-configured stage or a custom stage, and so that is actually a piece of configuration that you would bundle with Spinnaker when you go ahead and install it. So to give you a brief example of what that would look like, one thing that we do here at Armory is we have a number of automated tasks that we use a run job for. And so what the run job is going to allow you to do is it's going to allow you to define a Kubernetes manifest. So you could do something like apps v1, and then you could do kind pod. You have your metadata field, and then you have your spec, and that's going to have the container that you want to run and the commands that you want to run. But the thing is, you don't want to keep doing that for every pipeline, right? You can't extend it across pipelines. So what a pre-configured stage allows you to do is to codify this stage and give it a name and give it a location and all the configuration that you want, and it'll show up just like our My stage here, right? And then the third stage, or sorry, the third approach that you can take is to build a plugin. And building a plugin is one of the newest ways to extend Spinnaker. So if you've signed up for the plugin workshop, I believe it's going to happen directly after this one. You'll be able to see how to create a stage and expose that through the plugin approach rather than the approach we're going to take today. So many roads to victory here. We're just going to focus on one so that you can get your feet wet modifying these services. So I will take another pause for questions here. Otherwise, we will start installing Spinnaker.
So this setup you are showing here, on Kubernetes, or it's from your local machine?
Yeah, this particular deck UI that you're looking at, this is running on my local machine because I've already made the modifications here. But when we go in and install Spinnaker in a few moments, I'll show you how you can access the version of deck that is bundled with your Spinnaker cluster. Okay, so let's go ahead and start by installing Spinnaker. So if you recall at the beginning of the workshop, we created a new repository based on our template here. So I will post that link again, just in case. Go ahead and make sure that you create that repository and clone it to your local machine. For those of you who have already gotten to that point, let's go ahead and see what it looks like. So I'm going to go ahead and scroll up to the top here. So I'm showing you what that spinservice.yaml file looks like when you clone it to your local machine. And so many of you mentioned that you were familiar with Kubernetes. So I'm going to talk at a high level about what this manifest is doing. So this is a custom resource definition that is managed by something called a Spinnaker operator. It's a project that Armory has open sourced to help manage the installation and operation of Spinnaker inside of Kubernetes. So we have our open source API version here, Spinnaker.io v1 alpha 2. And then it provides a custom resource definition for a Spinnaker service. And so the Spinnaker service is going to provide the configuration that you would define globally for all of your services. And then it also allows you to provide profiles and service-specific settings within the manifest. And so essentially all you have to do at this point is go ahead and apply that to the cluster, and it'll create the Spinnaker cluster for you. So we're just going to talk about a few high-level config options. We're not going to go through the entire file. So what we're going to be installing today is version 121.0, which is the latest stable release of Spinnaker, at least as of a few days ago. And then we're going to use S3 for some persistent storage in Front 50. And we'll talk a little bit more about storage options when we take a tour of what is created for you. So what you're going to need to do now is open up this file in an editor on your file system, wherever you clone this project. And we're going to go ahead and modify this bucket. So we've already provisioned an S3 bucket for you. So you should be able to just go here to Gardening Days. Your file, if you've cloned it from the repository, will probably look like this, Gardening Days-fixme. So what you should be able to do is just change this to whatever the name of your namespace is. And if you can't recall what the name of your namespace is, refer back to the URL that you used to download your Kubernetes credentials, which we provided to you before the workshop started. And that'll be the name of the S3 bucket that was created on your behalf. So this is what we have here for our spinservice.yaml. And just so that I'm doing this all along with you, I am going to tear down my existing Spinnaker installation. So I'm going to go ahead and delete my spin service cluster. That might take a few moments. No, it didn't take long at all. Okay. And then what you're going to want to do is within the project, wherever you downloaded that spin service YAML, we're going to run this kubectl command. So just as a brief review, the credentials that you downloaded earlier, wherever you save them, that's going to be the argument to this kubeconfig flag. And that's going to tell kubectl how to authenticate to the Gardening Days cluster. Then we're going to choose our verb here, which is going to be apply. And then we're going to pass the F flag for a file and the spinservice.yaml file. So if we've done this, if we've configured this correctly, if your credentials are in the right place and you're referencing them correctly, you should see a message here that says spinnakerservice.spinnaker.io/spinnaker created. You can make sure that that's running correctly by running this get po command. Alternatively, you can write get pods. Get pods is the same command, just a little bit longer. So of course, I've got a few pods that are terminating here because I just tore down my old cluster. But if this is successful, you should start to see more services spinning up. So I'll take another pause here and just see how folks are doing. Are you able to create your cluster, or are you having issues so far?
Hey, Fernando, one thing I think we may have an additional namespace that needs to be provisioned. I may have dropped the ball on this. We have Ashish on the call. Who I says he didn't receive the email. So if you can do that, I can get him the message that he needs. If you can send it to me in Armory Slack. Thanks.
Sure. Yeah, let's take a look.
But these accounts are like empty ones, like there's nothing inside. Because when I log in, I see nothing in my account, like no pods, nothing. I don't know.
Okay. And you've gone ahead and run the supply F spin service YAML?
Yeah, I should run it. Yeah.
Okay. Yeah, once you run this command, you should start to see these pods being created.
I see 403 forbidden error, and because the bucket name should be like Spinnaker Gardening Days Workshop Config, something like that, or
That's a good question. So if we refer back to our spin service YAML, it should just be gardening days the last segment of the bucket that you received. So for example, for you in particular, it's probably going to look like Augustus Verbices, if I'm pronouncing your name correctly.
okay.
Okay, and Raz, I just sent you the credentials for Ashish, so we should be able to get going there. For other folks on the call, have you been able to see Spinnaker up and running?
Yes, Fernando.
Excellent. All right, so let's take a quick tour about what's running here, what the operator has managed to create for us. So just as a brief recap, what the Spinnaker operator is going to do for us is it's going to provide all of the configuration that we need to stand up a Spinnaker cluster. So it's a greatly simplified approach for getting a development cluster up and running. There are a number of ways that you can tweak the operator so that you can have a productionalized installation. And that's what we do not only internally to run our own Spinnaker instances, but what some of our customers do. So we're just going to quickly walk through. So the operator is going to create a deployment. So if you go ahead and do get deployments, and I will make sure that I don't clear the screen, you should see a number of deployments created on your behalf. And of course, these are all the pods that are going to be running. And one service that you might notice that's not part of Spinnaker itself is Spin Redis, right? So this is the cache layer and semi-persistence layer for Spinnaker. And I say semi-persistence because if you're familiar with Redis, it's not a durable store. So you will lose data if that Redis instance goes down. The reason that operator is creating a Redis instance for us is because it's going to simplify what we need in order to get going. So for a development cluster, Redis is totally fine, and all of the services know how to talk to Redis. If you want to productionalize your Spinnaker instance in your own environment, there are options for running MySQL instead, and that's a much more durable store, much more performant store for storing a lot of the information that you need. So I see a question from Sarud. The CRD was already installed in the cluster. Yes. So the CRD and the operator itself were already installed before the workshop started. We do have some documentation. If at the top of that manifest file, it'll take you to the CRD reference, but you can also click around our documentation site and you can see how to install the operator in your own environment if you'd like. All right, so it sounds like many of us have our environment set up. So we're going to go ahead and start talking about how we actually develop against the Spinnaker cluster. So if I go ahead and refer back to my notes here. So let's go ahead and start with Orca. So I'm going to talk a little bit about how, well, actually, before we do that, why don't we just make sure that our Spinnaker installation is up and running. So again, I'm going to have two splits here, and we're going to talk about how we can access our cluster when it's in this shared tenant environment. So what we can do is we can do a kubectl command, and we can go ahead and port forward. So I'm going to do two port forwards here. The first one is going to be for deck, and the second one is going to be for gate. Now, remember that you can get all of these commands from our workshop notes, but I will post them for your convenience in the Zoom chat here, since these are kind of lengthy. And the reason we're going to port forward these two services is because, remember our architecture diagram, deck is going to talk to gate, and then gate will talk to the rest of the services for us. So as long as deck can talk to gate locally, we should be able to go to our Chrome environment. We should be able to open up a new tab and go to localhost 9000. And if everything has been set up correctly, we should be able to see, well, in your environment, you probably will not see any applications, but you should be able to click around and even create an application here. So you can go to the upper right-hand side. I'm going to make this a little bit larger. Okay, and you can go up to the upper right here, and there's a little action button. It says create application. You can go ahead and create a new application. I'll call it workshop. I'll put my email in there. And then we'll go ahead and click create. So you should be able to see an empty infrastructure view here. And then over in pipelines, you can go ahead and configure a new pipeline, call it whatever you want. You can call it test pipeline. And that should take you to the pipeline configuration screen that we're going to be working with later on in the workshop. So I will take another pause here just to make sure that we're all on the same page. So at this point, you should be able to port forward, again, port forward deck and port forward gate to your local machine. And then you should be able to go to your browser of choice and navigate to localhost 9000, and that'll take you to this view. All right, so let's go on to the next step. Let us know in Zoom chat or just speak up if you're having issues at all, but we'll move on to the next step. So the next thing that we're going to talk about is a tool called telepresence. So I'm going to have this command up here in my top split, or in my only visible split now, and we're going to talk through a little bit about what telepresence does for us. So in order to explain that, let's talk about what we're doing when we're port forwarding these services. So what Kubernetes is going to do is it's going to establish a connection between the EKS cluster that we're running in and the local machine that they're working on. So we can port forward 9000 to our local machine, but it's not going to allow us to talk back to, or it's not going to allow anything inside of the cluster to talk back to us. So there's no way for the Kubernetes cluster to know about your personal laptop. So in order for us to be able to run a service locally and interact with other things in the cluster and have those cluster things interact with us, is to create a bidirectional channel that communication can occur. And so that is what telepresence provides. Telepresence gives you a bidirectional connection, and it does that by creating a container in the cluster that creates that two-way channel and then allows you to run a service locally that is configured to know about all of the other things in the cluster. And we're going to talk about exactly how that happens once we've got this command running. So the first thing we need to do is we need to specify kubeconfig. So for those of you who are familiar with Kubernetes, you'll know what this kubeconfig variable is doing, but if not, most tools that interact with Kubernetes will know to read this environment variable. Unfortunately, telepresence doesn't allow us to specify the kubeconfig via a flag. So we have to prefix our command and point to our configuration file, run the telepresence command. Telepresence also doesn't allow or doesn't read that file for namespace information. So even though it's provided in your kubeconfig, we're still going to have to explicitly tell telepresence what our namespace is. So this is mine in the Gardening Days cluster. And then we're going to tell it which deployment we want to swap. So in this case, we're going to be working with Orca. So we're going to swap the Orca deployment from the running cluster to our local machine. And then finally, we want to pass in this mfile flag. And what that's going to do is it's going to take all of the environment variables that are populated in the running container in Kubernetes, and it's going to proxy them to our local machine. So let's go ahead and run this. It's going to ask for sudo. And the reason it's going to ask for sudo access or elevated privileges is because it's using a tool, at least on Mac OS, called OSXFuse, which is going to mount the file system of the running container and put it in a location on our local file system. So if everything is working correctly, you should at the end see a special looking bash prompt at the bottom. If you're seeing an error here about not being able to mount the volume, then chances are, if you're on Mac OS, a recent version of Mac OS, like Catalina, for example, you're going to have a permissions error if you haven't run telepresence before. So you're just going to want to go to your system preferences, go to the security dialog, and make sure that you allow telepresence to interact with your machine. Otherwise, we know that we have successfully mounted the container if we are able to list the contents of telepresence root. And I'll explain how that variable is being populated in a moment. But what you should see when you do this ls telepresence root is the file system for the running container. And we know that this is the correct location by checking out the opt Spinnaker config directory. And we should see 3 files there: Orca local, Orca, and Spinnaker. The other way we can tell that telepresence is working properly is we can go ahead and inspect our cluster. And we can see now that there is an Orca pod with a funny looking name, like the hash is quite a bit longer than the rest of our services. And so this is evidence to you that the swap has been made. So we can also validate that by grabbing this pod name, calling a describe, or creating a describe pod call, and then go ahead and describe the pod as it is. And when we scroll up and we look at the image that is being pulled, it's not our Orca container anymore. Now it's the telepresence pod, which is responsible for creating that connection. So that's a few different ways that you can validate that this is running. I'm going to go ahead and paste this command here for the telepresence, for the describe call. Note that your pod name will probably be different, so you will have to make a describe call to get that. And then the telepresence command that we used, I can grab for you here as well. So we'll go ahead and grab that, paste that in. Yes, Ramesh, the deployment also changes. That is a good call out. All right, so how does that telepresence root variable get created? So let's go ahead and look at the contents of our .env telepresence file. So remember that we added this flag at the end of our command, and what it's going to do is it's going to populate that file with all of the environment variables that the container had access to in Kubernetes. So again, for those of you that are familiar, you should see all of the in-cluster service discovery variables being populated. So this is the IP addresses for everything that's running along with their exposed ports. And then at the very bottom, telepresence is going to include its own environment variables that, while you are in the context of this shell, are automatically loaded for you, which is why I was able to run an ls on the telepresence root directory and have it automatically figure itself out. You'll note though that if you're not inside of that special shell and you try and run the same command, you try and list the root of the telepresence directory, it's not going to work. Well, yeah. It's not actually defined as anything. So ls is just going to list the current directory in my installation. So you can get access to those variables if you want, if you go ahead and cat the env telepresence file, right? The same variables are still going to be there. And you'll notice that it's in a temporary file directory. So the reason that I'm explaining all of this is because we're going to want to copy the contents of our opt Spinnaker config directory to our local machine. And the reason we want to do that is because when we go and run Orca through IntelliJ, we need these configuration files so that Orca knows how to start itself up. So there are a number of different options that we can define, and several of those options is going to include, I'm going to run a cat on the Spinnaker YAML file so that we can talk about this a little bit more. Several of the options that are included is the location of other services in the cluster. Now, you're probably looking at this and you're wondering, how does this Kubernetes DNS name resolve from my local machine into the cluster? So that's another feature that telepresence is providing. It's actually going to modify local DNS entries on your system so that this resolves to the telepresence process, and it's going to route it into the cluster itself. So it's a nice, convenient feature. Although if you are on a corporate company VPN, or if you have a special network setup, then you might see some weird behavior. And unfortunately, I don't think we'll be able to debug that in this session in particular. So let's talk about what we need to do next. So once we have telepresence running, let's go ahead and run a copy command. So we're going to copy everything from the telepresence root. And if you joined us for a workshop yesterday, or you've previously worked on Spinnaker, you might need to remove that .spinnaker directory. So I'm just going to go ahead and blow it away, and then I'm going to run this cp command again, and I will go ahead and paste that into the channel here. Okay. So once we copy that, we should see nothing going on, nothing funny going on. And if we go ahead and list our Spinnaker directory, our .spinnaker directory, we will see the Orca YAML, Orca local, and the Spinnaker YAML file. So I think this is another good stopping point. So does anybody have any questions, or are they having trouble getting to this point? All right, Ashish has a question. He's asking, is the Spinnaker operator per cluster or per namespace? So there's two different ways that you could install the operator. You could install the operator in what we're calling basic mode, which will only have permissions within a particular namespace, or you can run it in cluster mode. And that's what we're doing here in EKS. So I have, we can even show you here. So we have a Spinnaker operator namespace. If I go ahead and get the pod, oh, that's because this is an old command with an old config file. Okay, there we go. So we're running it in its own namespace, but we're running it in cluster mode. So it has cluster level permissions to look at all of the namespaces in the cluster. And whenever you do, or whenever you apply a Spinnaker service, it's going to watch that namespace and make sure that it stands up a cluster for you.
So let's say I have 10 applications and they have 10 different namespaces, and they are 10 different teams. So what you suggest, should we go for per cluster or per namespace?
If they all need their own instance of Spinnaker, then you could run the operator in cluster mode, and you could have 10 different versions of Spinnaker running in those namespaces. But if you're referring to like applications, like the developers are working on applications, I would actually suggest running one Spinnaker and providing access to your teams to that Spinnaker so that they can deploy their applications. So you would have the operator running, and then you would have one cluster managed by the operator, and then all of your teams are connecting to that Spinnaker cluster.
So will they have a RBAC model implied? Let's say one team doesn't want to see other teams' namespace data and access.
Mm-hmm. Out of the box, there isn't going to be any authorization or auth-in features enabled. But what you can do is configure the operator to enable that functionality. So if you're using a single sign-on solution like Okta or Cognito in AWS, then you can actually provide role-based access to applications in the cluster.
Okay.
All right, so let's go ahead and let's start working on Orca. So now that we have our telepresence set up here, what we should do now is open up Orca in our editor. So we recommend using IntelliJ IDEA. You can use the community edition for free, or you can pay for the professional edition, which has a few more features. But either way, it's free to install for the community edition. So you can go ahead and type in IDEA dot. And what that's going to do is it's going to open up IntelliJ in the current directory. So for me, it's not going to do anything because I already have it open. So I'm just going to go ahead and move over to where I have IntelliJ up and running. Perfect. And so you should see something like this. Now, if you haven't opened up IntelliJ before and you haven't tried opening up this particular project, you're probably going to see a little status bar in the lower right of the screen where my mouse is right now. And you're going to see a lot of activity happening. So it's going to try and pull all of the dependencies for the project again. Hopefully, if that Orca build command was successful earlier, the dependencies will be pulled from cache, and then it's going to do a number of indexing operations in order for us to continue on with our project. So one thing that I would encourage us to do as well before we go forward is change to our release branch. So one thing that I didn't mention earlier is that we want to be developing against a stable version of Orca. So to talk about how the Spinnaker project is organized, all of these different services follow the same model. But essentially, if you look at the branches, master branch is where everything that a developer works on is going to go to. So if you're adding new changes, you're adding new features to Orca, maybe you want to contribute a new stage as a part of this hackathon, you're going to make a pull request to master. And then once a certain number of features is in there, it's considered stable, and we're nearing a release window for the next version of Spinnaker, then the release manager is going to cut a release branch. And so that's what was done a few weeks ago. They cut the release 121x branch. And now everything that goes into the branch is considered stable, and only things that are fixes are going to be backported. So in order for us to have a consistent experience for today, I want us to check out this release branch. So you should be able to git check out release 1.21x. I'm already on this branch, so it's going to just say, you know, you're already there, but you should see that this change happens here. And we're going to do the same for deck in a moment. But for now, let's continue focusing on Orca. So once you're in Orca, once you've got all of this index stuff finished, you should be able to click into any one of these files and make sure that everything is syntax highlighted. And we're going to do two things before we start writing code. So all of this stuff that we're talking about here, as far as the editor is concerned, is one-time setup. Once we've got all that done and working, we'll be able to work on the code right off the bat the next time we go in. So in order for us to have a successful session here today, I want us to install two plugins. The first one is going to be mfile. I'll go ahead and paste that in here. And if you're not familiar with IntelliJ, the way that I got to the screen is I hit Command, comma on my keyboard. Or if you're on Linux or Windows, it's probably going to be the Meta key or the Windows key. And that will take you to the settings dialog here. So the mfile plugin, we're going to install and then restart. And then the second plugin that we're going to want to install is the Lombok plugin. And for those of you that aren't familiar with Java development or have been out of the loop of Java development for a while, Lombok is a plugin that essentially provides macros, or what you would call macros in other languages, to implement boilerplate in your classes that is very tedious to write. So things like getters and setters, logging configurations, a number of other different annotations that you can add to your classes. And the reason we need this plugin is because IntelliJ will then be able to understand those annotations and give us intelligent auto completion for the things that we include via those annotations. So if you've installed this plugin, it's probably going to ask you to restart your IDE. So let's go ahead and make sure that that happens. And we'll go ahead and restart our IDE. So this is a good chance to take a break and open it up for any questions that we have.
I have a question from steps that was before, like when we go to localhost 9000 to the Spinnaker UI, I see only blank pages. What I should do to see something happening around?
Okay. Have you confirmed that you are also port forwarding gate? So there's two errors that we want, or sorry, there's two port forwards that we need to do. So in two separate terminals, we will run one for deck, and then in another terminal, we need to run one for gate.
Yeah, I did that.
Okay. So I'm wondering if there is somebody from Armory available to potentially help debug that with him in a breakout room. Akshay or Roz, I think you're the only two.
I'm here.
Sorry,
I'm doing some work in the background, and I haven't really been paying attention, so it'll take me a second to get to a debugging point.
That's okay.
Akshay, are you here?
Yeah, sorry, I wasn't paying attention either. What's up?
So we have Augustus is seeing a blank page when they go to the deck UI locally after they've done these port forwards.
I mean, it's not the whole blank. I see Spinnaker search projects, applications, like what I should.
Oh, okay. Yeah. Then in that case, if you can see all of this, that's fine. There's just no data configured in your browser. So, you can go to this applications tab, for example, like I'm showing here, and just go ahead and click on create application. And then that'll give you an application that you can start working with, and then click in.
Cool. So yeah, that's normal. It's just a blank instance.
Yeah. Yeah. So the first time you install Spinnaker, there's not going to be anything configured. So let's go ahead and return to our Orca exploration here. So I'm going to assume now that you have IntelliJ loaded up. You've got our two plugins installed, and we're ready to start talking about how we're going to modify the project. So let's think back to the goal that we wanted to accomplish today. We want to add a new stage to Spinnaker. It's just going to be called My Special Stage, and we're going to implement it here so that we have at least one task. And if we have more time, we can implement more tasks. So you're probably wondering what a task is and what a stage is in the context of Orca. So let's go ahead and take a quick run through of how the Orca project is laid out. So remember from our earlier conversation that Orca is an orchestration tool or service inside of the Spinnaker ecosystem. And so whenever you execute a pipeline, so whenever you go to the Spinnaker UI here and you execute a pipeline, that's going to, that's going to run all of these stages. And all of these stages in Orca are implemented by a number of tasks. And tasks are essentially just bite-sized. You can think of them like functions, right? So you're going to say, I want to execute a task. That task has a very specific function. It's going to go out and perform some action on your behalf. And then it's going to report whether it was successful or not. And it's going to report any information back to deck that was configured. So a stage, if we go to something like deploy manifest, for example, so if you're familiar with deploying things using a manifest, either in Kubernetes or some other provider that supports the stage, you'll notice some of these tasks, perhaps. So if we go to, we don't want the task. We want the deploy manifest stage. There we go. So if you're at all used to looking at the task status for a deploy manifest stage in Spinnaker, this probably looks familiar. So there's a number of different things that we can do within this stage, or that this stage is responsible for. And the way that we build up a stage is by building a graph. So that's what this task graph method is for. And task graph gives you access to a builder here as part of its function argument. And then you're responsible for registering all of the tasks that you want to have happen within that stage. So in this case, resolve the source for the manifest. That's a particular task. You can either do a constant name here, or you can do these inline string literals, whatever makes sense to you. And then you're going to have a task definition that's just a reference to a class. So for example, if we go back to our deploy manifest task, we'll see what a task looks like. And a task is also pretty simple. So it's going to implement an interface called task, and it's going to provide you with this execute method. So you're going to have access to all of the information that's available in a stage, and then you can take whatever action you need in order to consider that task complete. And then when you're done, you're going to return a task result, and task result implements the builder pattern. So you're going to provide a status, and then any context that you want to return, and then any outputs that you want to return to deck. And so just to give you an idea, you can return a number of different states in a task. So if you've ever gone into Spinnaker as a user and you've seen a pipeline is just taking forever to execute and this one stage is taking a long time, what's actually happening under the hood is those tasks are getting run multiple times and they're each returning a different status. So if you pause pipeline execution, then a particular task is going to return as paused. And Orca is going to requeue that task and attempt it again after it's done cycling through the rest of its work. So it's essentially going to take all of these tasks, throw it in a queue, and just start processing them all. And so we can provide a number of different states that are going to change how Orca handles that task. So we're not going to dig into many of these statuses today. We're just going to focus on creating one stage with one task for now that always succeeds. And then we're going to see how we can modify deck to represent that stage for us. So now that we've walked through that, I'm going to take one more moment to talk about how the project structure is actually laid out. So we're going to be working in Orca core today, which provides all of the core interfaces that you would need to implement for a stage. But when you're thinking about your hackathon project, or when you're thinking about where you want to take your stage for your organization, then think about where it fits into this hierarchy. So Orca has projects for a number of other services within Spinnaker. So for example, the deploy manifest task, if we go ahead and show where that's defined, it's defined in the Orca Cloud Driver package. And that's because this task is primarily going to be implementing or interfacing with Cloud Driver, because that's what's going to be applying this manifest to their cluster or deploying this manifest. Similarly, if you had a stage that was going to be interacting with Roscoe, and you were going to be doing something like baking an AMI or changing the way that the behavior works when you bake an AMI, then that would be implemented in the Orca Bakery package. But again, to keep it simple, we're going to stay in Orca core today. So are there any questions so far about how Orca is laid out before we continue going forward? All right, so let's go ahead and actually start writing some code this morning. So in the Orca core package, you're going to go down to source main Java, com.netflix.spinnaker.orca. I know that's quite a mouthful. But once you get down there, we're going to create a new class in this Orca package. And we're going to create a Java class, and we're going to call it my special stage. Okay. And I've told you to create this in the wrong place. So if you haven't created it yet, just go ahead and make sure that it's actually in the pipeline package. So one more level down. So you've got com, Netflix, Spinnaker, Orca, then in pipeline, and inside of pipeline, we'll have my special stage here. Okay. And so what you should see in IntelliJ is a bare bones class. Doesn't do much, not very exciting, but we're going to make it a little bit more exciting now. So in order to be a stage in Spinnaker, you need to implement an interface. So we're going to say implements, and we're going to call the stage definition builder. And if you're new to IntelliJ and IntelliSense generally, what you can do is you can hit tab here, and it's going to not only autocomplete the current word, but it's going to automatically import the right class that you need. in order to work on this project. So once we've got our implementation here, I'm going to use another keyboard shortcut. I'm going to hit Control I, and Control I is going to bring up this select methods implement dialog. And so IntelliJ can actually generate the methods that we need to implement along with all of the appropriate annotations for us so that we can focus more on writing our stage instead of actually fiddling with boilerplate code. So I'm going to go down here and I'm going to select task graph because we're going to register our tasks with Orca. And if as soon as I hit OK, it's going to generate that code for me. So I'm going to close the file browser on the left-hand side, and I'm just going to focus on the code here. So we can see our boilerplate for task graph. Now I'm going to go into task graph, and I'm going to take our builder here, and I'm going to call with task. And the other thing you can do with IntelliSense here is you can use your arrow keys to choose the implementation that you want. So I'm going to choose this first one that has a string name argument and a class that we're going to extend. And so let's call this, my stage start, just as an example name. And then we're going to reference a class that we haven't created yet. So I'm going to say my special stage start task dot class. You can also feel free to call this whatever you want. We're just going to keep it consistent. So if we have a my special stage, then we're going to have a my special stage start task. So you're probably going to see this red line here because this class doesn't exist yet, and that's okay. We're going to make a few more modifications here before we move on to the next step. So one thing that we haven't talked about to this point is that Orca and all of the Java Spinnaker services are implemented using a project or a framework called Spring Boot. And Spring Boot is an API framework, and it provides a lot of bells and whistles, one of the most famous of which is dependency injection, which is a strategy for inversion of control. So in order for our stage to be discovered by Orca, we need to hook in to that inversion of control, and we need to add an annotation here called component. So when I tab complete component, we should see org Spring Framework stereotype component. And that's going to make sure that our class is registered when Orca starts up. So we should be able to now reference this stage when Orca starts, and we can pull information from it when we build deck. So this is all that we need in order to create a new stage. Of course, you can get much more complicated, you can get much fancier, but we just want to keep it simple so that we have something working. So we have our component here that is called my special stage. It implements the stage definition builder, and we override this task graph method. So this is another good stopping point to check in. Have folks had trouble accessing this project, implementing this class, or are we all at this point now? Okay, let's go ahead and continue. So the next thing that we want to do is we want to implement the my special stage start task. So in order to do that, we're going to stay within our pipeline package here. We're going to go down to tasks, and we're going to implement a new task. So in the same way that we implemented our task before, we're going to right click on the package, select what? New, and then Java class. And we'll put in my special stage start task. And if you change the name from the implementation here on my screen, then make sure that the task name matches what you have in your editor. So when we go ahead and implement that, we're going to get a class similar to what we had before. It's not going to be very exciting, but just like the stage, we're going to implement an interface so that Orca knows that what we're doing is defining a task. So we'll go ahead and define task here and tab complete so that we get our import here. And so you should see this showing up in Orca API pipeline task. And then you're going to see some red squigglies in IntelliJ. The reason you're going to see that is because we actually need to implement methods for this contract. The reason we didn't need to do so for stage definition builder here is because if we click into the implementation here, this interface provides default implementations for a number of different methods. Task does not provide that for us. So what we're going to need to do is we're going to use another shortcut here. We're going to type Alt, Enter, and a little dialog is going to show up that gives us the option to implement the methods that are necessary for this task to be considered implemented. So it's going to highlight exactly what you need. In this case, the only thing we need to implement is the execute method. So I'm going to click OK. And now that's going to create the boilerplate for my task execute method. All right. And then just for the sake of having something very simple, let's just return our task result, and we'll implement our builder method here. And we're going to say, I want you to always succeed. So we'll pull in this execution status.succeeded. And then we will call build. And so this is all that we need in order to implement this task. But I'll reiterate from our earlier conversation that this execute method is really where you make your API calls to other services, do some useful work, or otherwise implement the contract of your stage. Okay. Now, there's one more thing that I'd like us to do here. You can reformat the code if you like, but you can also keep it on one line. I'm going to add one more call to our builder here called outputs. And outputs is the way that we can pass information about a certain task result back to deck, back to the UI, so that we can render it properly. So what we're going to say here is we're going to call, so this is going to accept a map, right? So one thing that we can do is we can hit Control J over anything in the IDE, and that's going to bring up this little dialog here. And I know that's a little bit small to see, but if you do it on your own screen, you should be able to see that outputs takes a map of something that extends a string and returns something else. So in this case, we only want to return one key. So we will refer to our collections util package, and we'll create a singleton map. And the key, we're going to call stage start status. And we're going to refer to this key in deck. So the name of this key is important, and then we will return the message that we want to return. So you, again, can do many more complicated things with outputs, but for the purpose of the workshop, we're just going to return a simple string. Now, there's one last thing that we need to do. Remember that we were talking about Spring Boot and how we need to provide annotations for things to be discoverable by Orca, that is using the Spring framework. So we're going to add our @component annotation here. And now at this point, we should have a fully formed stage. So the last step that we need to do is we need to go to My Special Stage, and we need to go and hit Alt-Enter above our red class name, and it will automatically import the task that we created just now. So now, with these two classes, we should have something that's fully working. So is there anyone that's had trouble getting to this point, or have any questions about the stage definition or the task definition? All right, so let's talk about how we're actually going to run this service. So if I look in the upper right of my project, I see a configuration here for Orca Web Run. So that's what we're going to get to. So when you go up and click on that definition here, you might not see anything here. You should still be able to click on it, and you should see a label that says Edit Configurations. So when you go ahead and click on Edit Configurations, you're going to be taken to this dialog box. And so what we're going to want to do is take our mouse to the upper left of this dialog and click plus. We're going to want to add a Gradle configuration. And then in the dialog box here, we'll see a section for Gradle project. Let's go ahead to the right and click on the folder with the blue square. And that's going to give us all of the packages that we were talking about earlier. And we're going to scroll all the way to the bottom, and we're going to choose Orca Web. And Orca Web is the project that's actually going to spin up the API for us and allow us to interact with the rest of the services. So we've got Orca Web defined here. And then the task that we want to execute is the run task. And so now we should see the name of our configuration has changed. And then refer back to the conversation that we were having about telepresence. And remember that there is an environment file that contains all of the information for us to talk to other services. So in order for us to be able to configure that for our services, we need to go, so you should see this configuration tab. You go 2 over in the center of the dialog and you click on M file. We'll go ahead and enable the M file. And then in the bottom of this table here, we're going to go ahead and click on plus, and we're going to add a .m file. And what you should see at this point is a dialog box that shows you the current directory for your Orca project. So if you're like me and you haven't configured your Finder window on macOS to show hidden files, then you're not going to be able to see the .env telepresence file. That's perfectly okay. Choose the first file that you see in there and open it. And then you can go into the path section here. You can double click on it, and then you can type in .env telepresence. And you'll know you're successful when this .env telepresence stays highlighted as it is. If it starts to show up red, that means that IntelliJ can't actually find this file in your current directory. So chances are you ran the telepresence command in a different directory from the root of the Orca project. So what you're going to want to do is copy that environment file into the root of your Orca project so that this M file continues to work. So once you're done, you can click apply and you can click OK. I'm getting an error here because I already have the task defined. So I'm just going to go ahead and remove it. And I'm going to leave my existing configuration, which has this M file set up. So when I click OK, now you should see the little elephant here along with Orca Web Run. And we can go ahead and click on that green triangle. And this is the point where we're actually going to start the service. It's going to compile all of our changes in, and it's going to allow us to talk to services within the cluster. So you're going to see a number of warnings on the left-hand side here. That's perfectly okay. As long as you don't see any errors that will prevent the service from starting, you can safely ignore a lot of the warnings that you're seeing here. You might also see some red text when you're starting up the service here. That's okay too. A lot of the time they're just warnings. And while this service is starting up, I'll talk to you about a few of the things that could go wrong. So one of the most common errors that people see is a fiat permissions evaluation error, and it's going to fail to start Orca. So the reason that you're seeing this error is because when we went to our telepresence directory, we didn't copy our files over, right? So remember in our gardening days command here, we were supposed to copy this file to our tilde.spinnaker directory. So that's one common error that you would see. Another common error that you would see is unable to connect to Redis or unknown host for Redis. And typically what that means is that the connection has been broken for your telepresence mount. So that means that you might still see this shell, you might not, but some issue has occurred between telepresence and the cluster that you're talking to. The other potential issue is that Redis is not running in the cluster, but that is far less likely. So usually the fix there is to just restart telepresence, and then you can run the service. So what you should see, if this was successful, is a message here. Right here, this is usually the message that I'm used to seeing. So it'll say started main in 12 seconds, JVM running for 13. You might see different time values there, that's okay. And then if you have previous executions, like I do in my cluster, then you're going to start seeing log messages for all of these other services talking to Orca because they want some task executed. So I'll again take a pause here and just check in with everyone. Have we been able to start up Orca? Have we been able to get it to talk to everything else in the cluster? Okay, I will assume that this is all working correctly. So we have our Orca service running. Now, if we go back to deck, we should see everything is running correctly. We shouldn't see any issues. For me in particular, I should, oh, interesting. I need to get my deck port forward going here. Excellent. Okay, so we should still see everything working here in deck, but we shouldn't be able to see any changes. So what we're going to want to do is modify deck now so that it understands this stage. So in order to do that, we're going to leave this running and we're going to switch over to deck. And I'm taking a look at our time here. And so just to save on a bit of time, I'm going to provide us with the code that we're going to need in deck. Now we're still going to review everything, but we're just going to save ourselves a little bit of typing so we make sure we can see everything that we need to. So I'm going to go ahead and take this file. I've just pasted it into the Zoom chat. And so this is all of the code that we're going to need to render our special stage in deck. So while you go ahead and grab that, one thing that you're going to want to make sure you do is go ahead and hit Control-C on this port forward here for deck, because now we're going to start a local copy of deck. You can go ahead and leave the port forward for gate, because our local version of deck is still going to want to talk to gate. But we should be able to switch over to our deck environment, and we're going to start working on deck. So as we mentioned at the very beginning, deck is the UI. It's the portal for users to interact with Spinnaker. It is currently a mixture of Angular on one hand and React on the other. So Angular v1 was the original framework that was used to create deck, and all newer functionality is now being written in React. So if you're not super familiar with front-end frameworks, that's okay. We're not going to make you learn 2 frameworks today. We're really just going to be focusing on React today. So React, for those of you that are not front-end gurus, is a framework for creating rich web applications. I'm not a marketing person, so I'm not sure of the best way to sell it. But basically, it gives you a way to quickly build interfaces in JavaScript. So I'm going to go ahead and just quickly go to the directory that I need to for this to work. It looks like I already am, so I'm going to go ahead and go in there. So what you're going to want to do in deck is you're going to want to create a directory called MyStage in this kind of long path. And we're going to break down what exactly this path covers. So everything for the application is defined in a top-level app directory. Then scripts modules core is going to be the module that we're working in today. Similar to how Orca was laid out, deck has a very similar file structure. So it's going to have a core module. It's also going to have like a Kubernetes module. It's going to have an Amazon module. So that's where all of the platform-specific module or JavaScript is going to live. And then within this core module, we're going to define a source, or we're going to be working in source pipeline config, and then stage, because we're adding code for a new stage. So you can go ahead and explore this on your own time, and you can see how some of the other stages are configured. Again, you might see a mix between React and Angular, and today we're just going to be focusing on the React side of things. So the first thing we need to do when we're going to add a stage to deck is we're going to need to register it with the pipeline registry for deck. So this is a component that's defined as a part of the deck project. So this isn't a React a piece by itself. It's a registry that deck uses in order for it to understand what is available. So we're going to call registry.pipeline register stage, and then we're going to provide an object that defines a number of values that we're going to talk about now. So the first thing that we're going to talk about is the label. So the label is what shows up in the deck UI. So bake manifest is a label, deploy service is a label, destroy service is a label. So that's what we're going to define here. We're just going to call it my stage. Then the description is what's going to show up directly below that label. So for bake manifest, for example, it's going to tell you exactly what it's going to do when it's baking that manifest. And then the key. Now the key is very important because the key is going to correspond to the stage name that we defined in Orca. So remember in Orca, we created a stage that was called my special stage. And what Orca is going to do when it goes to decide how to execute something, it's going to look for calls from deck that say my special. So notice that the stage is kind of like cut off. So we're going to define the key here as mySpecial so that it calls the mySpecial stage. And then the last three things that we're going to define are components, execution details, and validators. So I'm actually going to skip ahead and I'm going to talk about validators briefly. They're a little bit out of scope for the changes that we want to make today, but validators allow you to, if we were defining a bake manifest stage, for example, would allow you to define validations that have to occur before you save a pipeline. So for example here, if I was attempting, well, apparently it didn't work for bake manifest. That's a poor example, but we're going to talk through them anyway. So let's assume that I had a validator for the render engine for this bake manifest stage. If I had a validator that said I must have one of these three values, Helm 2, 3, or Customize, then if I attempted to save without selecting something, it would actually prevent me from saving. So that's what this validators field is responsible for. Now let's return to component and execution detail sections. So a component, this is React terminology now. So a React component is one that contains logic for rendering and executing a component, and then all of the display code that is responsible for making that show up in the UI. So I'm going to go ahead and show what the definition for my stage config is. So we have a typical React component here. I'm going to go ahead and close this file, and I'm going to show you what this looks like. So we're going to create a class that extends a React component of type stage config props. And then we're not going to do anything special here. And the reason we're not going to do that is because our stage doesn't actually accept any arguments. So there's nothing to configure here. But just for the sake of being complete, we're going to define this empty stage config. And where that is going to end up getting rendered is this block right here. So for example, this bake manifest stage, it has one single config option, which is to choose the render engine. And then it's going to render more options depending on what you choose. So Customize is going to look a little different. Helm 3 is going to look a little different. Ramesh has a question. How is this mySpecial key identifiable by Orca? So when you make an API call to Orca, it's going to look through. Remember, Spring Boot is essentially allowing you to register components. So when you make this API call, that mySpecial key is going to be used by Orca and the Spring framework to discover the class of that same name. So that's why we need to append our stage there, because it's going to look for a stage with the mySpecial prefix. Does that help answer your question? So for example, if we defined a stage I don't know, deploy car, right? If you wanted to deploy, if you had a deploy car stage that was going to, I don't know, like execute an API call somewhere to have a car shipped from a factory, then the key that you would define here would be deploy car. And so Orca knows how to associate that with the stage based on the way that you added that component to Orca. All right. So the last thing that we're going to talk about here is execution detail sections. So this is when we're going to see this in a moment when we actually run the pipeline, but this is actually going to determine the information that is displayed in the little drop-down box that shows up when we actually execute a pipeline. And so I'm going to quickly show you what my execution details looks like. Okay, we're going to go ahead and open read only. Okay. And we're going to look at what this looks like. So this is, again, going to extend another React component. We're going to define the title for this box that we want. And then we're going to render some configuration here. So if you're not familiar with front-end technologies, this might look a little bit strange. This doesn't look like JavaScript. This doesn't look like HTML. So if you notice the extension for this file is .tsx. So this is a TypeScript extension file. This is essentially blending a typed version of JavaScript together with some HTML-like syntax. So what we do inside of this special render method is we render all of the other React components that we want, and then all of the information that we need for those React components. So for example, an execution detail section, this is a React component that was defined somewhere else in the project. It accepts some arguments that we pass in, and then we can embed our own content inside of this detail section. So what this is going to end up looking like is we're going to have a detail section, and then within that, we're going to have 2 fields that are conditionally displayed. So this is some special JavaScript syntax here that essentially says, if this outputs value has a key called stage start status, and it's non-empty, this is a JavaScriptism. This is essentially a truthy value that will always return true if it's non-empty. And we have this content defined here, then this component will render. And again, it's okay if we don't understand all of this at once. I myself am not a front-end person, so I'm recently getting up to speed with React. But this is how we would conditionally render a component in the user interface. Now remember, outputs is a special value that we're getting from the stage context. So this is where Orca actually returns the information that we need to render this stage. So if we look back to our Orca implementation and we go to our task, we should see that we have our outputs is going to return a stage start status. And so in our deck code, we're just going to return whatever we had in this output section. So that's what we're doing here. We have our outputs, we have the key, and then we're going to render that value. And we should see that value rendered in deck. All right, the last thing we're going to talk about is this execution detail tasks. So because this is an array, as long as it's an array that implements a detail section, it's going to render along with everything else. So this execution detail section is actually going to be important for you to expose to your users how long each task is taking within your stage. So if we had in our implementation, in our stage, if we had registered maybe 10 tasks, then that execution detail section would understand exactly how long it took each task to execute, and it would display that information in the UI. So this is a very handy piece of code to implement. So while you've been hearing me talk about all these things, hopefully you've been able to make this directory. You've been able to place these 3 files inside of deck. And there's one last thing that we need to do in order for this to be registered. So we've defined all of the code, but we haven't actually imported it anywhere. So if you go to app scripts modules core, which is the module that we're working in, and then source pipeline, so essentially 3 directories up from where we were working on our stage, there's going to be a pipeline.module.typescript file. And inside of that file is where we're going to register this component. So we're going to import a relative path to config stages my stage, and then we're going to pass in the top level my stage file. And at that point, we should be all set to go. So we can go ahead into our terminal and we can type yarn start. And what yarn start is going to do is it's going to spin up a local service. It's going to host all of the deck resources that we need, and it's going to connect to a localhost version of our gate instance. So at this point, you should stop your deck port forward from the cluster, but you should keep your port forward for gate. We're going to sit here for a moment and we're going to watch deck build. Are there any questions so far? I understand this front end stuff has been very quick so far. All right, so let's go ahead and talk about some of the output that we're going to see here. So you're going to see a lot of red output for warnings. These warnings are a-okay. They're just warnings from the build process. A couple of things that you might see here if this isn't configured correctly, you might see build errors from missing dependencies. If that's the case, I would encourage you to run yarn again without any arguments, and that will make sure that it pulls down all of the resources that you need to run the project. But if you've managed to start this successfully, you should see 3 messages at the bottom. No type errors found, the version of TypeScript that you're running, and the amount of time it took to compile. So at this point, deck is ready to go. So I'm going to go ahead and I'm going to type in localhost 9000. I'm going to click leave. And so what I should see, if I've been able to start everything correctly, is the Spinnaker UI. So I'm going to go ahead and go to applications, I'm going to go to my application. Whatever you called your application is fine. I'm going to go to the configure pipeline step here, and I'm going to go ahead and add stage. And if we've done everything correctly, at the very top of the list, we should see my stage, along with the label that we defined in deck, the description that we added, and we should see no configuration options like we were talking about. I'm going to go ahead and save the changes here. Then let's go ahead and go back to executions. And again, if we've wired everything up correctly, we should see my stage execute when we go ahead and run this pipeline. So we'll go ahead and click in, and it looks like our pipeline has succeeded. So congratulations if you've been following along and you've gotten to this point. You have added a brand new stage to Spinnaker. It's not very useful, but you have accomplished something. So let's go ahead and talk about some of those components that we were talking about earlier. So remember the detail, execution detail section. So here is my stage status, and here is the output that we got from Orca. It's always going to return hello for now. But if you want to validate that this is working every time, you could change that string to a timestamp. You could change it to a random number. You could change it to anything you like and just validate that this information is getting populated back. And then finally, there is a task status view here. And that's, again, going to show you the time it took for all tasks in that stage to execute. So in this case, it didn't take very long at all because that task is always going to succeed. But if you were going to do something more interesting, like make an API call, either asynchronously or not, and maybe return a task status, then this is where you would see that duration continue to tick up. So does anybody have any questions for us at this point? All right. So I will reiterate that everything that we've covered in the workshop today is in this Spin Contrib workshop. So I'm going to repost the link from the very beginning. And let's see, copy this link, and I'm going to paste it down below. Ramesh, I'm so glad to hear that it's very clear to you now. That's exciting. So if you want to review any of the things that we've done here, again, this recording is going to be posted afterwards. But this link is also going to give you a written guide of what we've covered today. I'll also reiterate the plugins workshop is going to be starting soon, I believe in about 20 minutes here, but it might be, I don't know, maybe Roz can confirm for me. So that plugins workshop is going to show you how to approach this pipeline stage edition, but through the plugin framework.
That's right. The plugin workshop starts in about a little less than 20 minutes.
Excellent. So I would encourage you, if you've RSVP'd, to attend that workshop because it's going to give you a different perspective on how you can extend Spinnaker. But hopefully what you've gotten out of this workshop today is you've understood not only how to install Spinnaker in a co-located environment, but also how to develop against Spinnaker and run services locally. And the reason that we like this approach at Armory is because not everybody has the same laptop, the same processing power. We want to be able to modify these services without having to worry about too much. So this approach allows us to run Spinnaker in the cluster and then only modify the services that we need locally. So hopefully you found this workshop useful. I'll stick around for a few more minutes if you have questions, but otherwise, thank you for joining us today, and good luck with the rest of the hackathon. I'll also mention that you have this environment for the duration of the event. So if you want to continue hacking on Spinnaker with your teams during the hackathon, you can just continue to use this cluster. We'll leave it there until the end of the hackathon.
Thank you so much, everyone, for engaging in this workshop, and big thanks and shout out to Fernando, who led the charge in developing this training and delivering it to you all. We're really, really grateful to him for that. Okay, well, first we'll stop streaming live on YouTube.
Okay.
My step.
Good first step.
Goodbye, YouTubers. We love you.
Goodbye.
I hope you have the doc. I put it in the description.